Hello, this is an ENGI 460, and we're using Monte Carlo and MATLAB to solve optimization problems. So for this Monte Carlo algorithm, first of all, there's three different questions. The first is a simple minimize with constraints. The second is another minimize with a upper and lower bound constraint. And the final problem is a TSP problem, and that's what I'm going to go over with you today. So in this traveling salesman problem, we're trying to find the shortest tour of randomized XY coordinates, and it's going to be a 10 by 10 distance matrix that we create. So I'm just going to run through the pseudocode and then show you it running. But we initialize the number of stops, the randomized X and Y coordinates, the number of iterations, for example. And right here we create our distance matrix, so we get the size of that XY. And we run two for loops to loop through those rows and columns and take the Euclidean distance between the points and create a distance matrix with a diagonal of zeros. Going into the Monte Carlo aspect of it though, we start by creating 100 randomly generated routes. We set our best route equal to infinity so that every other route that this loop runs through will be less than that initial start point. But then we start by finding our random permutation, which is our first gene, and then our route, which will basically circuit back to the original starting point, so we ensure every city is hit and we go back to the start. And so here we're looking at our cost. So this is the main chunk of the loop, but if the cost of the current iteration is less than the best, our new best will be that cost we just found. And then we will keep track of which count that best was found at. Here is the Monte Carlo aspect of random numbers. So we randomly generate values for R1 and R2, and these will be between 1 and n, which in this case is 10. So we replace the lesser population with the best, mutate these, and we output a comparison of the optimized array. So it would be, if it's went route 1, 3, 5, 8, and so on, that's the one with the shortest distance. We'll output that, as well as a chart detailing, just a visual for you. And here below is our cost function, where we just use a loop to sum up and calculate the total minimum cost of our optimized route. So going into our code, we have it here, and it's basically pretty much what I've showed you previously. We're going to run that code, and this is our final route we get. And then going through the code, our answer, these are the distances generated from our cost, and this is the optimized route that we have found to be, to generate the shortest tour. So that essentially, that's all I'll show you for now, because it will be here a while if I show you the rest of the problems. But that concludes this Monte Carlo simulation. Thank you for watching.